Are you looking to analyze rent prices for an entire city or county? Well, in this video, I'm going to show you how to get rental data at the zip code level using Python. My name is Ariel Herrera with the AnalyticsAriel channel. We bridge the gap between real estate and technology. Current rental data is hard to get for free, but now it does not have to be using APIs that update data monthly. This video will be split into two parts. First, we will get the rental data for all zip codes in a county. Second, we will visualize the data in Tableau so that we can easily spot trends and emerging neighborhoods. We'll be able to do this all for free. And if you also enjoy data-driven solutions like me, then please subscribe. As well, like this content if you want to see more rent data solutions. All right, let's get started. For this tutorial, we're going to be using Python in order to get rental data. So make sure you make a clone of the notebook, which is in the link below. This will open within your own Google Drive so that you could run Python in the cloud. That way you don't need to have it personally installed on your own machine. So for the first part, what we want to do is run our imports. We're going to use outside libraries. So we can either press play or we could do Control-Shift-Enter in order to run the cell. Now once this is run, we've loaded in our libraries. And our next step is now optional. This is where I actually pull in my own Google Drive file where I have all my API keys stored. Since API keys need to be private, and don't worry, we'll get to the part where you bring in your API key. So right now I'm just loading in to connect with my Google Drive. I gave permissions. And in the second cell, what I'm going to be doing is assigning my API key to a variable called rapid API key. And this is the part where you're going to replace with your own key. So let's look at that now. We're going to be using RealtyMole property, which is an API that gets information monthly by zip code for rent data. And RealtyMole allows us to actually use our API for free. We can make 50 API requests, and anything after that is 5 cents afterwards. So what you'll need to do is make a free account with Rapid API, and then once you do, you'll be able to come to RealtyMole site. In their About page, if you want to learn more about them, you can look on their website. They have not just rental owner data, but they also have property data, absentee owner lists, and more. Now if we go over to the endpoints, which is what we care about, towards the bottom, we are going to look at the rental market data endpoint since we want to get rental data for an entire zip code. But they do have other endpoints to be aware of if you wanted to get comparables just for one particular property. So for us, we're just going to need zip code, and what we could do is go over to Python, and we can copy the code that's going to be here. Now once you sign up, you'll see that you have your own API key on the right-hand side. Make sure you copy that and replace it where I have my Rapid API key. So the first step we want to do is get data for a single property. So we paste in the sample code that came from RealtyMole, and we replace the string with our own Rapid API key. We can also replace the zip code that they have. So in this case, I'm going to use the zip code in the Tampa market, which is my market. So I create a variable called zip code, and here I'm going to type in the zip code that I want to get data for, 33610. Now I run this, and once we run this, we're basically passing into the endpoint, please get data for our zip code. And we get lots of information back down to the bedroom level. So for each month, we're going to have information on what the average rent is, whether it's a studio, single bedroom, 2-bedroom, and more. Next, what we want to do is actually see this data in an easier format. So if we look at it on JSON format, we can now see that's a little bit more readable. And if we go all the way to the top, we could see that we have our zip code as an ID. We also have our average rent, and we have more detail on what that looks like. We could look at studio, bedroom, 2-bedroom, and see max and min rents, as well as how many rentals currently exist within that space in the market. And we also have historical data. So let's bring this over into a table that we can actually read with rows and columns. So here we're using Pandas library and JSON normalize in order to normalize this response. So let's look at the number of rows as well as the number of columns that we're going to have in our data set. So we could just modify this quickly to cols and look at the length of columns. Now we can view the top results, which in this case we're just going to get one result because it's just one zip code that we got data for. Now that we have the data, we could see here that we have a single row and we have 141 columns, which is a lot. So what is in these actual columns? Well, we could see we have rental data history dating back to 2020 of April. And we have data that goes all the way to June of 2022, which is the most recent month as of this recording. What we want to do is actually get this historical data. Wouldn't it be awesome if we can have a trend analysis to actually see what this rent has changed from 2 years ago till now? We could see emerging zip codes if we do this. So the first thing that we want to do here is see how can we dynamically pull these columns. So what we're going to do is look at all the columns that we have within our data set. And we want to pull the ones that have history and that are detailed. So what we do here is we're going to loop through each of these columns. So for each C, so C is going to be our variable here. If detailed and history is in C, and we want to keep those columns. So here we could wrap this into a list, and now we see we have all of the rental data history columns for every single month based on us just filtering it out using a for loop. So let's set this to a variable called rent detail history column. And now we can actually iterate through each of these columns so that we can pull the data from it. Our goal again is to have one single table or one data frame that has all historical detail for these rental prices. Now we want to actually pull that date that comes from the column. So what we're going to do is look at our first element within the list. And when we run it, we see here that we have 2020-04. So let's split this by a period so that we get closer to getting our element. And this is in the second piece of our list. So let's index it to 2. And now we see we're able to get our date. So we can copy this and just modify it slightly. This will be X instead. And we could set this to a variable so that we have our date as a string. And if we want, we could print this so that we could actually make sure our script is working. I frequently do this when I'm creating for loops. It's each time I add a step, I just test it using print. And we could see we have all of our columns now have month as well as year. Next, what we want to do is basically get our column name dynamically. So if we look at one of these columns, they're called rental data history with the month and year. And then it has average rent, which in our case, we only care about average rent for this example so that we could look at average rent across history. So here we set our variable called detail column, and we're going to modify this part. And instead, we're going to replace it with our date string. That way, as we go through all the columns, we're dynamically pulling the average rent for that date. And now we could see that we've set all of our months to have that information. Let's now get this data into a data frame so that we'll be able to actually view it as rows and columns. So we're going to convert this historical data to a data frame, and we can set up our data frame as _df since it's temporary, and then wrap it in Pandas data frame. And for our other data frame, df rent, we're going to pull that new detail column that we specified up top. Once we have our column that we want to get data for wrapped into a data frame, and we're selecting the first element there, we could run this. This works fine. So now let's create a couple of columns that we also want to have in our data frame. And then we'll run it so we could see what this looks like. So our date string that we were able to pull, let's make this into a column so that we know which month and year our data is associated with. Second, let's do the same for a zip code as well. Now, what we want to do is each time we get information on a particular year and month, we want to put this into one single table. So we want to have all historical data together. Therefore, we create an empty list that's going to store each of these subtables that we've created per month and year. So once we run this, we can now look at our results. So if we look at a single data frame for that month and year, which is June of 2022, we have all of our average rent by bedroom, and we also have the zip code associated. So let's now join all these data frames together. We use pd.concat to do so, and now we have 765 rows of historical data. We can set this to its own data frame name as well, and add some commentary up top so that we can remember why we created this. So now we have our new data frame called DF Detail. It's basically all the historical detail that we were looking to get. Although we have our data, we do see our important columns, date string, and zip code all the way at the end. And because these are our unique identifiers, we want to see those columns towards the top. So if we go to functions, we'll see that I already created a function to move columns to the front of our table. So make sure to run that function, and then we could go back down so that we can move those two columns to the front part of our data frame. Great, we can now see that we have our date string at the front of our table. So next, let's just copy the previous code that we have, and we can change the column that we want to move to the front, which is zip code. And now we see zip code is our first column, then date string, exactly how we wanted it. But now we want to add some more features. We want to see how has our rent changed from the previous year? Has it decreased? Has it increased? Does this mean that it's been increasing for several years and maybe it's an emerging market relative to other zip codes in the area? Well, here what we're going to do is first label what is the previous year. So in our case, I'm going to use a lambda function. And before we finish our lambda function, let's just try this out with one single row. So if we grab our date string and we grab the first item, we'll see here that we're going to have 2020 of 04. So we want to get the previous year, but this isn't a string. So now we're going to have to actually modify this and bring it back as a date time object. So we're going to wrap this variable with date time, and we're going to specify what is the format. So here we have year and month. So once we run this, we could see now our object is a datetime format where we have our year, our month, and we want to subtract one single year. So we're going to use relative delta so that we can subtract 1 year. And if we run this, we'll see now that we have 2019, exactly what we're looking for. But we need to get this back into a string format. So we use our datetime string ftime function, and now we have 1 year going back. Awesome. So we could bring that into our lambda function, which will allow us to apply this to every single row within our data frame. And all we have to do is replace test with the column that we're going to be using. And for readability, I'm just going to move this down, run this, and now for every single row, we have a column for previous year date. Perfect. Next, we're going to add our features so that we can have the previous year data. So we're going to copy our current data frame, and we want to have a second data frame that has data for the previous year. So what we're going to do first is we want to rename our columns. Therefore, we're going to get all of our columns into a list, just like we did previously. So we're going to label each column variable as C. So for each column within our table, what we want to do is add a prefix or suffix to it called previous year. Once we correct our variable and change it to C, then run this, you'll see now we have our data frame, but it has previous year for each of our columns. That way we're going to be able to differentiate which columns are from the last year versus the current once we merge these two data frames back together. Great, so now we're going to use df merge. So it's panda's function called merge. And if we go look at it quickly, you can search it into Google, pandas merge. It should be the first link for documentation. And we can look at all the different parameters that we can enter. As well, we can see examples of how it's been used. So I highly recommend to go to the docs when you're using new functions so that you can understand them a bit better. So the first step to merge two tables together is we're going to have our left side, so our DF detail, then our DF detail previous. We want to join these, preserving the left-hand side. And for our left data frame, we want to join on previous year date column as well as on bedrooms. So we could see that previous year column, and then bedrooms. Next, for our right-hand side, so our previous year data frame, it's going to be a bit different. The columns are instead date, string, previous year, and it's going to be bedrooms underscore previous year because that was the suffix that we gave those columns. Now we can look to run this and view the top 5, which in this case we just get null values because we don't have data for 2019. So let's look at the last values of our data frame, which is 2022 of June. And now we could see we have additional columns for 2021 of June. We could see our average rent of this year and our average rent from the previous year. This is huge. This is going to allow us to see trends year over year. So let's remove any duplicates that we have. And now we could see the information for each bedroom. We could see bedroom 4. And this is great. Now our next step is we want to add several features so that we could actually look at year over year changes. Before we do that, let's quickly just look at more months within our data set. We could see here that for studios, we have a big issue. The average rent is $121,000, which we know cannot be true. We must have some bad data there. How do we identify this bad data and do it in a statistical way? What we can do is identify outliers using z-score. So what we're going to do here is set up a new column where we have average rent, and we're going to get the z-score. Then we're going to get our column, average rent. We're going to apply z-score here, and we're going to see that we have a new column that calculates the z-score. For our z-score, we could see that that value that's very high is at a 3, and another value, 3.6. So we can easily filter these out by removing any records with average rent of a standard deviation that's greater than 2. By filtering on our data frame by 2 different parameters, we can filter on bedrooms as well as the average rent score so that we can have our z-score less than 2. And when we look at this here, we have eliminated studios because studios in the zip code 33610 was above our threshold of a z-score of 2. And let's correct our bedrooms here so we're not having anything that's more than 5 bedrooms. As I've seen with this data set, there's a lot of missing data or also anomalies when it's over 5 or at 5. So now what we could do, that we have a filtered data set, we can drop any columns that aren't really necessary for us. And there's several here that we obtained when we did that join with the current year and the previous year data frames. So let's just remove anything that's not related to average rent price. Now when we run the cell, we can see we have less columns. For our previous year data, we just have information that we care about, like the average rent, min, and max. Awesome. So now we have a data set that is clean and filtered, and we could add our last features here, which are going to analyze our year over year change in average rent for each of these bedroom types. So what we do is we set our new column. It's going to be called year over year average rent. And what we want to do is take our newest average rent, which is in this case 2022 for July. And what we want to do is create the formula that will subtract from last year's rent and divide by it. So I'm going to quickly show you what this formula looks like as well, so that you have an idea of how to do this on your own too. But once we have these columns complete, I could look over to percentage change calculator. And here, this is just a public free percentage change calculator. And I use this just to make sure I do my formulas correctly. So what we're going to do is go to our table, and we could select the average rent for one of these rows. So for 3 bedrooms, let's just take this number. So this should be for June of 2022. And now let's get the previous year, which is about 1,500. So let's copy this, put it into the calculator, hit calculate, and we could see we should get a value that the rent went up by about 33 or 34%. So now we go back into our notebook. Let's quickly fix this column over here, run it, and once we run it, we can look at our new column, and for that particular row, we are able to see that we have an increase of 33%, so we know that our formula is correct. And now we could just duplicate this to also look not just at average rent year over year, but also total number of rentals. In this cell, we could now see, if we go all the way to the right, that we have our additional column of year over year change in total rentals. This can help us to see if demand is exceeding supply and how hot an emerging market may be. Great. So we've been able to get information on a particular zip code and look historically of how average rent has changed by the bedroom. But we want to be able to get this information not just for one zip code, but for all zip codes for a particular city or county. So let's do that next. In order for us to find all zip codes that are relevant for a city or county, we're going to need to get a data file of all zip codes mapped to city or county. And in order to do that, we can do a quick Google search, which I'm going to show you right now how to do. And then I've already put our previous code into functions, so we'll be able to quickly run the same steps that we just took within a matter of seconds to get our data set that we will then populate into our Tableau visualization within the next video. The first step to obtaining our data set is by looking on Google US State County Zip Code Data. So I'm going to click the first link, which is from GitHub, and it says, sorry, data's too large. You need to view it raw. So if we look at the data set raw, we can see if we type in Hillsborough County, which is the county for Tampa, that we're able to get all the information on the county, including the cities and the zip codes. Great. So we want to pull this information from within our notebook. I'm going to be copying over some previous code that I've written. So here we have the URL that we just looked at. And by using pandas read, we're able to see there's 33,000 rows of zip codes and 6 columns where we get county, city, and state abbreviation. What we want to do is get all the information for Hillsborough County within Tampa. So here I take our data frame DFGeo and I look for Florida and Hillsborough. Now we see that we have all of the zip codes in Hillsborough County. Great. However, we do have an issue as we're looking at it. There's some invalid zip codes. It's not actually a real city, and it's not numeric for all 5 of the elements within the zip code variable. So here we're going to check if it's a valid zip code or not by testing if it's numeric. So see, we have here, check for the column zip code is numeric, and if it's not, then it should be false. So we should see that all of these are true since all the numbers 3, 3, 5, 10 are numeric, but then we see false since HH is not numeric. We'll be able to filter on all the bad zip codes so that we can have those removed from our data set. And if we quickly look to see how many of those invalid zip codes we have, we can run this quickly when we have that filter. And here we're going to see that of all of our zip codes labeled Hillsborough, there's 47, 45 are true that they're valid, and the invalid ones, there's just 2 of them. So what we could do next is filter to make sure that we only are obtaining those valid zip codes. So I do this here in the next cell. I state for the column valid zip code, only select those that are true. And we could see that we have our data set, and in total, we have 45 valid zip codes, which matches what we saw in the group by. Perfect. Now we can iteratively run these zip codes through the code that we worked with previously. In order to not waste API credits, I'm going to show you a notebook that I've already created that goes through this information and obtains all data for the zip code. So first, in the functions above, we want to make sure that we run each of these. We've now taken our getting the market rental data into a zip code where all we do is pass the Rapid API key and zip code. We check to make sure the zip code is valid and that it has 5 elements. Then we return the data. We also have functions to get the latest rental data, and also we have a function to get the historical rental data. That was the meat of our code in the last section. We also have our features towards the very bottom. So make sure you run each of those functions and then go all the way back down to where we just got all of our valid zip codes. Please be aware before you run this code to look at the pricing. So if you are looking at, say, 100 zip codes, you're going to exceed the free API. So be aware of that. And if you're going to look for, say, zip codes throughout the entire United States, you may want to upgrade to Pro, Ultra, or Mega for your pricing package. So next, what we're going to do here is iterate through each zip code in our list. And there's going to be only a few steps within our for loop. It's pretty clean since we have functions. First, we are going to get the rental data once we pass in our key and zip code. Once we have that response, there are 2 things we were doing. We're going to get the latest rental data, so only for the current month. In this case, 2022 of June. We get our latest rental data and we append it into an empty list. That way we can later consolidate for all zip codes. Also, we want to get historical data. And historical data is going to follow the same steps where we append it to a list. We do a try and except so that in case there's any errors, we print out which zip code had the error, and we have to sleep for 1 second. If we go back to the documentation, RealtyMole states that you can only make 2 requests per second. Therefore, after making those 2 requests, we pause for 1 second. We could see here that when I ran this, I was able to get all of the data except for 1 single zip code, which I could always troubleshoot in the future, but at least everything ran. Then I use pd.concat in order to get all of our data frames into one single large data frame so we have all zip code data. Now, what's really interesting is being able to look at this information at a historical level. This data set is a lot larger. It's over 1,000 rows where we have all the zip codes and its historical information for average rent by bedroom. We could see here the breakout of those as well. Then we want to get this into a CSV format so that we can upload this into Tableau for our visualization. So I have it dynamically that things are being saved down or downloaded based on the latest date. As well, for the historical context, I merged this with our file that came from GitHub so that we could see county, city, and state for our zip code. So next, meet me in part 2, where we're going to go over how to create this same exact visualization, but you'll be able to do it with your own city or county. And make sure at the very end of this file that you download it so that you could see all the information. And it's going to come up within a CSV file. You're going to have a lot of data here, but we'll be able to work with it really easily within Tableau. And we could see within the spreadsheet, we have our information on average rent by bedroom, by zip code. If you found this tutorial useful, then please comment below and like this video as it helps to promote for others on YouTube to find this video to help them with their own analysis. All right, and if you haven't already, please subscribe. Thanks.